Hello, everyone. My name is Salman. I'm a solution architect at AWS, and today I want to talk to you about how you can automate wind turbine inspection using machine learning on AWS. Quick agenda before we get going. I'm going to start with a little bit on how things are typically done. Then we're going to move to a future state architecture that is cloud agnostic. And then finally, I'm going to map that to AWS specific services and show you how you can build this inside of your AWS console. All right, let's jump into it. So the oldest and most common form of turbine inspection is the manual inspection. This is where a turbine technician goes to a farm and they put on a bunch of rope climbing equipment and then they get hoisted to the correct height. And then they take about 3 to 6 hours to do an inspection of the turbine, depending on the turbine size and weather conditions. And then they come down, they report those findings via some sort of internal process. And if there's things that need to be fixed or looked at, then there's a reporting mechanism that is usually internal in most organizations to do that. Now, as you can imagine, there are probably some limitations to scaling this. The big one is time. Even if you have 2 to 3 inspectors looking at your farm, they're only able to do 2 to 3 turbines a day. So if you have a sizable farm, this is not cost effective or time effective. Second thing is that human error is a factor. So different inspectors have different qualities of inspections, and you might get varying results depending on who is actually doing those inspections. The final one is that there are angles and parts of the turbine that certain inspectors just can't see. There are also federal regulations that guide things like how far a turbine inspector can go inside of a turbine blade. So there's limited visibility on certain aspects of that. Now, for all of these reasons, many organizations have started integrating or completely using drones to do their turbine inspections. This is great, right? There's a lot of benefits to using drones. You can see from this architecture that it's a pretty similar approach. You just have the turbines, then you have a drone that is either set up to automatically take off and do these inspections, or you have a pilot that comes on site, flies the drone, takes pictures, and then those pictures are fed into a turbine photo repository. And then an inspector looks at those photos, determines if there's something wrong, and then again, uses a reporting mechanism to alert. So this is pretty great as there are lots of benefits associated with it, such as time. The latest generation of wind-resistant UAVs are able to do these turbine inspections in as little as 45 minutes. Those drones are also able to capture really high resolution images, which makes it easier to spot defects that may have been missed by technicians. And technicians are also allowed to remain on the ground in this approach, which reduces things like liability and insurance costs. Also training them to fly a drone, or even better, training just a drone pilot to fly a path and take pictures for those engineers to review later is way cheaper than sending them up. That's why the University of Manchester found that drone-based inspection is able to reduce operational costs by around 70% and decrease revenue lost to downtime by about 90%. So that's the case for drones. The next problem that needs to be solved here is the volume of photos, because at this stage over here, there's still lots of photos that are taken. These turbines can be the size of football fields, and so up to thousands of photos can be taken, and this inspector has to manually look through them to see if there's anything wrong. So today we're going to focus on how we can optimize this portion and make it faster. So let's jump into a generic future state architecture that could solve a problem like this. So we're going to begin same as before. We're going to start with a turbine and a drone that is either flying automatically or programmed to fly a certain path, or maybe there's a pilot there. Doesn't matter. That drone takes pictures that are then fed into an ingestion device that is sitting at the edge at the farm. That edge device is just a small computing module that is able to receive photos and send those into our image repository, which will be in the cloud. So once we have those photos inside of the cloud, then we're able to use an existing machine learning model to detect if there are any problems that are associated with that photo that we have. And I didn't include this here, but there of course would be another repository where pictures that were used to train the model would have to be stored and continuously added to improve that model. We'll talk more about that later. Next, we need a place to put those results, which is a repository. That's going to be our results repository. And then finally, we have to connect that repository to some sort of reporting mechanism that is going to alert the responsible party in your organization if there's a problem. So we can also integrate some visualization, some alerting to tell us, things like, has this turbine had problems historically? Let us know what parts that we need to replace, that kind of thing. So that's a high level look at the kind of services that you need to be able to pull this kind of architecture off. Here we have an AWS architecture. So we're going to match that future state architecture with specific AWS services and show you how you can build this on AWS. All right. So this is going to start with ingestion. And of course, there needs to be some sort of module at the edge to do this. For the purposes of this demo, I'm not going to discuss that because whoever is implementing this is going to have certain hardware partners that they want to work with, certain modules that they prefer to use to compute with. So I would recommend something like this, where you're using Greengrass with an edge device, a Raspberry Pi, whatever it is, to send these pictures into S3. But if that's something that you're interested in, reach out to me at djsalman@aws.com and we can have that conversation. But for the purposes of this, I'm going to focus on the core part of this, which is the S3 all the way to the notification. So let's assume that you have some sort of mechanism. You've sent the photos now into S3 and they're stored in here. And if you don't know what S3 is, S3 is our storage. It's our object storage service. So you've probably never seen an architecture without it. It's fast, it's scalable, it's highly secure, and it does what we need it to in this case, which is to store those turbine photos. So we're going to upload these photos into S3. And then once they're in S3, it's going to trigger something called an upload event. And that upload event is going to wake up this Lambda, which is going to uh, run some serverless compute. And if you don't know what Lambda is our serverless compute offering. It essentially runs code without provisioning or managing servers. So it's organized into a functional approach. So it's the ideal compute option here because we don't have to worry about a server that is going to run all the time, costing us money. It just wakes up when it needs to, when there's a photo uploaded, and then it goes back to sleep when it's not doing any work. So that Lambda wakes up Amazon Recognition, and Recognition is our image and video recognition service, which is able to detect a long list of things using including faces, text, scenes, activities, so on. It's based on the same deep learning technology that Amazon's computer vision scientists use to analyze billions of images each day. It's designed to be really accessible and require no machine learning expertise. So this is really accessible to everyone. Amazon Recognition is going to use an API called detect labels to find custom labels based on training data that is provided in another bucket that we have here. So this model has been trained, right? So when this Lambda triggers recognition, what it's saying is, I want you to analyze the photo that is sitting inside of S3 and let me know if there's a problem with my turbine. So recognition will do that, and then it will let the Lambda know that result is called an inference. So once that inference is returned back into Lambda, then Lambda is going to store those results inside of DynamoDB. DynamoDB is our fully managed NoSQL database. Fully managed means that we don't have to worry about provisioning hardware to support it or maintain it. It's highly available, highly durable. It's able to scale up and down the throughput without taking downtime or a performance hit, and it has on-demand backup capacity and archival capacity built into it. So there are other alternatives that we can explore here, but since all we're looking for is low latency responses to high traffic queries, DynamoDB is the well-architected option. So we're going to store the data inside of DynamoDB. And once that happens, DynamoDB is going to wake up this Lambda, the second Lambda, which is going to store our business logic using something called DynamoDB streams. And what it's going to tell the Lambda is here are the results that we have, and the Lambda is going to use those results to make an assessment. So, for example, if the recognition labels model detected that there was a delamination on the turbine blade, then the Lambda would have the business logic to say, for example, Salman is the person at this company that handles delamination problems. Let's forward that problem to him. And that forwarding happens over here in Amazon SNS, which is our notification service. So it's pretty straightforward. It lets you asynchronously send messages to subscribers, and recipients are able to subscribe to SNS topics to receive published messages using things like Lambda, HTTP, email, mobile push notifications, SMS. There are a lot of ways to reach out to people. It also supports application to application notification. So if you want to connect this to your internal application that distributes, where these notifications go, you're also able to do that. So once that happens, then the owner of the problem is notified and they can respond to whatever problem was detected on that turbine. And of course, we have CloudWatch here just to provide some metrics on different AWS resources that we have, collect logs, that kind of thing. And we have IAM for authentication. All right, so this is what the architecture is going to look like. Now let's actually build this thing. So we will be following instructions based off of this blog right here. Shout out to Burak for building it and templatizing it, making this easy to use. But before we begin, we're going to go back into this console and we're going to build our model because that's going to take some time and run in the background while we do everything else. So if you have recognition handy here in the recently visited, click on that. If you don't, just type it here and it'll come up, and then we're going to go into that service. So you're going to click up here on custom labels. It's going to give you some instructions. You can click get started. You're going to have a nice 2-minute video here that explains how this works. And that's worth a watch. But we're going to jump down into the projects here to actually build this thing. So I have a model here that already exists, but for your purposes, you should use US East 1 just to make things simpler for the rest of this video. So before you do anything, make sure that you are in US East 1. But for my purposes, I'm just going to switch to a region that I haven't used before, just so I can get the same startup screen that you would see in US East 1. So it's going to take me there. Okay. And you're going to get this prompt that says, hey, you never used this service before. We need a S3 bucket to store your project files. Go ahead and create that. Click on that. It should run automatically. Take a second because I'm using a region that is very far away from where I am. Create project. Give your project a name. Turbine blade model is fine. And then first thing will be here to create a data set. So create a data set here. You can use S3, upload them pictures, or use custom labels, ground truth. There are a lot of options. We're going to use S3 because that's just going to make things simpler for us. And there's a feature here where if you're uploading an image folder and you have the training data in different folders, so let's say you're training pictures, a model to recognize dogs, you have a folder where you put the golden retriever pictures. The model is going to use that label for these pictures and so on and so forth. So it makes it really easy to label your data. So we're going to create an S3 bucket where we're going to be storing our photos. We need to go to S3 here. So if you type S3 here and then right click, you can open it in a new tab. I'm going to close this one. It's going to take us to the console. You can see here that I have a few of these already, but this is the one that we just created right in the Mumbai region. We're going to create an S3 bucket to store our images. So we can call this whatever. We can call this Turbine and Model X And then you don't have to mess with any of this. Just create that bucket. Oh, forgot about the uppercasing. Model picks that. We're going to create the bucket. Okay, so this is what we just created. There should be nothing in here. And we're going to upload content into it. So you're going to come here. You're going to click Add Folder, and then it's going to open up a pop-up. I've hidden mine just so you don't see my personal folders, but you will be clicking on the folder that I've attached in the description. Let me upload mine here. The folder will be called Blades. Okay, and you can see that there is a normal folder, and then there'll be a broken folder as well. So click Upload. These should take a quick second to upload. All right, so photos have finished uploading. So now let's go put those into Rekognition. So remember, this is where it's asking for the URI. So we're going to go grab that. That's here. So just copy that and then paste it here. And remember, it's inside of the blades folder. So we're going to add blades. And then for this to be valid, you have to add a backslash. And then this is very important. Make sure to tick this so that it knows to assign the different folders as different tags to associate the images with for the training. Then you have to come here to make sure that you have these policies associated with your S3 bucket, or else it's not going to be able to run. So we're going to just click on this and copy it. And we'll go back into that S3. We'll go out into the actual bucket. Then we're going to do permissions. We're going to scroll down to bucket policy, and we're just going to paste this in here. Edit first. Here. Then save those changes. And once we've done that, then we can create our data set. It's going to run for a second to create our data set. And once it's done, yep, there we go. Then it's going to direct us here. And you're going to see these photos that you've trained. These are just a sample turbine pictures that have been uploaded. And you can see all of the folders that were inside the broken folder. All the files that were inside the broken folder have been assigned this tag, and then all the normal files were assigned this one. So these photos are just a sample turbine that I had in my house, and I put these little stickers to indicate if there's broken, and if there's no sticker, then it's not broken. Just very simple to showcase the machine learning capabilities here. So this model will have to run to train, and it's going to take about 30 minutes to an hour. You can start that over here. So click there and then start training that model. It says 30 to 24 hours, but this is very simple. And so it should be pretty quick. But because I don't want to make you all wait, I'm going to go back to that initial region where I have a trained model already, US East 1. So here you can see I have already trained the model and have this ready to go. So this is the model that we're going to be using to do the inference on the photos that we've uploaded. So now to build everything else that we looked at, right? So now we have this portion that is in motion, and now we're going to build everything else. So we're going to go into a terminal, just open up a terminal, and then you're going to clone a repository. We're going to be following instructions based on this blog post. Shout out to Burak, who's also a solution architect at AWS, who templatized this and made this very easy to use. You can follow his blog to essentially build all of these resources. But if you just follow along, I'm going to show you how to do it. So first, you need to clone. Well, first, you need to download the AWS CLI and the SAM. So if you go into the respective documentations here, it's really straightforward. If you have a Windows, you just run these 2, 3 steps, you get it. And then next, you do the SAM, same kind of thing. You just follow the instructions. It's pretty well documented. So get these, get that, and then you also have to have Docker and Python running. The instructions for those are pretty straightforward. That's download Docker that way, and Python also just simply download it from the website. So I'm going to assume that you grabbed all of these. And once you have all of that, then you can actually start following along. So you start here by cloning this repository, and you can grab that link from the comment section, or the caption rather. I think I already have this folder here. So actually I'm going to create a subfolder just so I don't have conflicts. We'll call this ML demo. The name means absolutely nothing. Just create a folder. Then we'll cd into that ML demo 3. There should be nothing in there. If you ls, and we're going to git clone it. Okay, pretty quick. We have that folder. Now we're going to cd into it. If you ls, you'll see there's a folder called AI-based wind turbine inspection blog post. We'll cd into that tab. It's going to automatically pull that up for you. That's the shortcut. All right, now once we're in there, then we're going to cd into the SAM repo, cd SAM. And once we're in the SAM repo, then we can build this. So SAM build, and it'll take a second to run. All right, and it'll tell you the deployment instructions. So one typo here is that there's only one slash here. So you need 2 of these to get, not slash, dash, to get this to run. So make sure you use these instructions and not those. So SAM deploy dash guided. And you're going to get these instructions. It's going to ask you for a name. You can just use this name right here. I'm just going to copy this, reopen my terminal, paste that in there. Then we're just going to use US East 1 and make sure that that matches what you have here, which is why I told you earlier to deploy all of this in US East 1 because it's just going to make things easier. But if you did it in another one, make sure that you choose this specific region or else it's not going to work. So since our model is deployed in US East 1, we're just going to do that. I'm going to click enter. You don't have to type anything. Everything here is the default, right? And then for your DynamoDB table, you can just leave that as well. Then you have your input bucket. You can just leave that as it is, or you know, create a specific one if you want. And then you have a custom labels endpoint where you're going to attach this model once it's done. So if it shows you that it's still running, you kind of have to wait. But if it's done, click on the model and then click here and then click use model, and it's going to provide you this resource name, Amazon resource name, and that points your deployment to the specific model, which tells it to actually run using this model. So you're going to just paste that there. You can right click it in. Then you're going to add an email address. This is where you're going to receive that notification email based on the model running, right? This model, this turbine picture you've uploaded is broken. This one is not broken. Just enter your own email in here. I'm going to not type my email in here because I don't want to make that public, but just, whatever, right, at gmail.com. And then the labels, For this, we're just going to type broken in here. We're keeping it generic. This is the threshold for which you're going to be notified. So this is how sure the model is that the picture that you've uploaded reflects the inference. And then it's going to tell you confirm these changes before you deploy. And then you're going to click yes. You're going to click enter. I won't do that because I've already done that and it's going to break things. But once you click yes, then it's going to run your model and create infrastructure based on the information that you've provided here. So since I already have all of this, I'm just going to jump into, let me just make sure there's nothing else that's going to stump you all. Yep, input names, SNS, and then yeah. All right, so that should be it. And then once you've uploaded, once you've clicked yes, then those are going to start running, and you can see them running if you go back into your console and go to cloud formation here. Cloud formation. I don't have anything in the Mumbai region. Let me switch back to US East 1. All right, so you can see here that this is what it's going to run, and then it's going to tell you that it's complete. It's going to give you status updates, right? And then once it's complete, then you can actually use this to test your specific implementation, right? So one thing that I've noticed breaks a lot on this is the SNS. And I'm not sure why this is. I've tried to fix it, but just to make sure that this is going to work for you, go to topics here, click this, and then verify that your email is subscribed. You should receive an email that says that you've been subscribed to this notification once the stack runs, and you have to confirm that before. And so if the status shows confirmed, then you should be good to go. Once you have that, then you can actually run this and use it. So how do you do that? You start just as we saw in that architecture with this S3 upload, right? You can do that programmatically if you know how to, or you can just do it from the console, which is the easier option. So I'm just going to do that. I can click here, 3. All right, so to actually see if this worked, then we're going to upload a photo into S3 to be able to run the model. So if you remember, it starts at S3, goes to the Lambda, the recognition, stores the results, and then it should notify us, right? So we're going to test if that works. We're going to upload an image into S3 here. This will be the folder that you created. Remember, this is the one I created in the example, but this is the one that is actually associated with this specific implementation that I did before. So I'm going to go into this one. There's a bunch of tests that I've run in the past, but let me upload a fresh picture. So in an ideal world, you don't want to use the same pictures that you use to train it, to test it, but because you don't have access to the turbine that I use to take your own pictures, and this is just a demo, you can use those same photos. So go into that blades folder. Uh, let's give it a good name so that we can recognize it. We'll call it turbine demo. We'll save that, and then we will upload that specific picture. So that's uploaded now. And now we can go into DynamoDB. DynamoDB, see if the recognition model ran and stored our inference, right? S3 Lambda recognition, DynamoDB. So we're checking here to see if our results have been stored in there. So if we go to that table and we go to results table, then we go to explore table items. We can look here. Yeah, here it is. So the picture that we uploaded, turbine picture demo. We can see that we have that there. Told us that the picture that we uploaded is broken, which is indeed correct because remember it had those dots on them. Gives you the normal confidence is 0, broken confidence is 100. This is what the inference is, and this is where the photo is stored. All right, so it stored the results, but did it actually notify us? Let me put up my email, and I'm going to do it on my second screen over here, just so I don't share personal information. And as you can see over here, it notified us. So just 3 minutes ago, or this is the previous one, just a minute ago, it sent a error that says confidence 100%. Check out the photo that we uploaded. And if you look through here, you can see Turbine Pick demo is in there. So end to end, we've been able to upload a picture. We put that in a Lambda. Recognition recognized it. DynamoDB stored those results. And then we have a Lambda here that is actually storing the logic to execute this. Now, finally, just go to CloudWatch here. So if something were to break when you were trying this and you wanted to see what was happening in the background or see metrics, then you can go to logs here, log groups, and the logs are stored over here. So you can see the logs for today, for example, that are associated here. Everything ran fine. So thank you for joining. And if you made it to the end of the video, I appreciate that. I hope that this was useful. Let me end better. So that's the demo. It showcases you how to do turbine inspection on AWS. I hope that this was useful. If you have any questions, please reach out to me at djsalmon@amazon.com. I will also put that in the description. And I will see you in the next video. Thanks.